Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. I would now like to welcome Dahnesh, Allan, and Vivek, our speaker for today's session. Dahnesh is the CTO for Azure at Microsoft India. Our next speaker, Allan, is a senior cloud solution architect at Microsoft India. And of course, we have our Azure Happy Hour host, Vivek, who works at Microsoft as a senior cloud advocate. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. With this, I would like to hand over the floor to Vivek to begin the session. Over to you, Vivek.
Hey, thanks, Rashmita. And I would like to welcome Dahnesh and Alan for Azure Happy Hour. And this has been a very amazing journey for Azure Happy Hour as well. And it's I personally do deliver a lot of sessions on Kubernetes, and I do demos and hands-on demos on Azure Kubernetes Service and other things. But I have never had a chance to have a discussion on how to consider Kubernetes Azure Kubernetes Service, right? And why we should consider Azure Kubernetes Service. This is something learning for me as well, which it is a good journey for me as well. I would definitely like to hand over things to Dahnesh to take this forward, and I will be there. Obviously, I'll be asking questions, and I will moderate the questions as well. So one of the things which I would like the audience and ask audience is, please make sure you ask as many questions as possible in the chat, and also we will take questions at the end as well. But please post your questions in the chat so that we can collectively answer those questions. Danish, over to you.
Thank you, Vivek. I just want to confirm, if I'm audible.
Yeah.
Okay, perfect. And Alan, if you can just bring up the slide deck. So first of all, welcome to all the participants, and thank you, Vivek. Thanks, Rashmita, and again, welcome Alan as well for being the, obviously partnering with me and kind of delivering the session. So firstly, I'm very excited to be a part of this community. And Vivek mentioned the number of developers who've been part of this community is absolutely amazing. So big congratulations to the entire community for kind of bringing all this, I would say, sense of interaction and collaboration together for very interesting and important topics as a part of our all journey of the way we progress into the cloud world. So we're going to speak about today Azure Kubernetes Services, zero to hero. So that's going to be the sort of, I would say, the how to say the word launch into the next maybe 50 to 55 minutes in terms of what we're going to kind of walk you through. And I speak to a lot of customers, partners, chief architects, CTOs. I would say day in and day out, and obviously over the past 2 years during pandemic, it has been all about working virtually and now sort of working hybrid. And it brings me to an interesting thought process, and kind of Vivek also teed it off saying, the idea of running Kubernetes. Okay. How is the evolution happening? And the evolution is happening with this entire construct of application modernization. And Alan, if you can just go to the next slide. In fact, what we're going to speak to you today is when we think about modernizing apps or building new applications, the first thing that comes to everyone's mind is how do I build something which is native to cloud? To kind of leverage the goodness of cloud, leverage the capabilities around reliability, security, scale, but at the same time make sure my applications are agile. They're absolutely scalable, and they can run in an elastic mode across a variety of architectures. What we have for you today is, I would say, three tranches of discussion points. First is when you're thinking about Kubernetes, obviously thinking about containers. But when it comes to containers, how do you really run or host them on Azure? What are the options that are there in this massively scalable, I would say, cloud? And how is this developer friendly? How is this friendly in terms of making sure that you also respect enterprise security and privacy of data? How do you ensure that the areas like, I would say reliability, areas like scalability are kept as a first party design principle rather than afterthought when it comes to hosting containers or running this as a part of a broader orchestration engine? We're going to then talk through in terms of Azure Kubernetes Services as a deployment, I would say, set of options, right? And how do you really run your containerized apps and other augmented apps, which may or may not be running in containers, but still talking over a vast variety of APIs, for example. And then we're going to walk you through some of the best practices, that we have learned, we have heard from the folks in the community, from our customers, from our engineering teams. So to bring that, I would say, the knowledge base onto this community, so we can share that and also learn from you. As Vivek mentioned in the beginning, we would love to have this as an interactive session, and Vivek is going to help me kind of pause in my section, and then as Allan takes over in his section to interact with you and sort of answer any questions and take thoughts and feedback from you. So Allan, if you can go to the next one. So running containers on Azure. So we thought of, Allan, if you go to the next slide, we thought of why don't we start off this particular happy hour talking about maybe a pop quiz, and I'm sure Vivek knows the answer, but we wanted to pose this question to you. How many ways are there to run containers on Azure? And you could put that onto the chat, and we will then give you the answer. But is it 5, 10, 3, or 7? So let me just pause for maybe 4 or 5 seconds and see if we can have some of these on chat as well. And would encourage folks to, so I can see there's an answer 5. Let's wait for a few more, and then I'll obviously answer that. There is 10, okay, 5, broadly 5, 3. Okay, maybe give it a couple of more seconds. So I can see a lot distributing between 5 ways or 3 ways. Okay, so let's give the answer away, Allan. And there is 10, by the way, 10 different ways, and we put this together into a single slide. And Allan, if you go to the next slide. So there are actually 10 different ways. And, Allan and I were speaking about this. Actually, there's 11th way also to run containers in Azure, but if you look at the landscape, or if I have to use the word as a technical professional, the various options that I have got, the choices that I have got, where I can take a container app and bring that into the Azure landscape of technologies, I would say there are definitely 10. And the idea is to make sure that as a developer, as an IT professional, as an architect, as a CIO, CTO, as anybody who has to take a decision on what should I do next with that container app, we want to create the choice of deployment and the control back to you to make sure that when you are thinking about the evolution of that app, whether it's a brand new app or whether it's an app that you bring from an on-premises based deployment option or any other cloud, from virtual machines into I would say containers and then into Kubernetes. The idea is to make sure that choice and the control is back to you. And again, I'll just walk you through, let's say for the next 15 seconds, you can bring containers into Azure Web Apps and make highly scalable, I would say, apps. We can, in fact, support Linux as well as Windows containers in this particular construct, or you can bring them into Azure container instances and run out, your app by container as well. Again, Linux, Windows containers supported. You can bring that into Azure Batch as a service, Azure Functions. So you can run serverless, which is what Azure Functions is all about, and bring containerization as a focus area. And obviously, again, here it's only Linux containers that are supported at this point of time. And then we can bring in, Azure Container Apps as well. And the list can go on. It's Azure Red Hat, OpenShift as a service, or it's Azure Spring Cloud for bringing in maybe Java Spring Boot or ASP.NET Core sort of apps into this particular construct, or use Azure Service Fabric. Or if you're looking at building a hybrid way of running your containerized apps within Kubernetes, you could use Azure Arc as well. So in summary, if you look at when you start on the journey of saying, I want to bring in, containerized based apps and then bring that into an orchestration engine as the overall goal of app modernization or bringing cloud native apps, the choice and the control is to you, as somebody who's deciding on that particular technology. What I'm going to do is now invite Allan, who's our senior cloud solution architect, to walk you through some of the learnings, best practices, deployment options in context of Azure Kubernetes Service. And again, as Vivek said, and I will reiterate that point, let's make it as interactive as possible. We want to hear your thoughts as well, understand if there is any feedback that you want to share with us. And yeah, let's have a great session going forward. Thanks again, and I'll stay on for questions as we move forward. Allan, on to you.
Yes. So just before we go to Alan, there is one specific question basically on this particular slide. Difference between Azure Kubernetes Service and the Service Fabric. What are the difference between these two services?
So I think the first focus is the idea really is to make sure that, as I said earlier, the idea of choice and the way you want to deploy your applications, right? So if you're looking at having Kubernetes as an orchestration engine, right, you will look at Azure Kubernetes Service, which basically is a fully managed Kubernetes service for you. So that's the first option. But if you're looking at distributed system platforms that, for all practical purposes, you can have, again, as it Linux as well as Windows containers within the service fabric construct, which has been there for a few years now, you can use that as a choice as well. The idea, again, and see, bringing in 10 different options for running containers, the point is, depending on the use case, depending on what is the end result that you want to achieve, we want to make sure that you have those choices. Right. And you will always, as a developer, as an architect, come across this particular point where you will say, which one should I choose? Right. And each of them have their own goodness and a point in time, what's their applicability. So again, it's choice and it's a spread that you would see across the spectrum. And that's the way I'll view it, Vivek, as an architect. Yeah.
I think you can go ahead, Alan.
Yeah.
Thanks.
Perfect. Thanks, Alan. On to you.
Yep. Quick mic check if you can hear me okay.
Yes.
Okay, thank you. All right, so now that we have seen the many different ways of running container applications on Azure, let me walk you through a sort of like a decision guide on what platform should you decide if you bring in a containerized application, right? So as Dahnesh mentioned, so if you have a web application or an API app, which is in a container format, you could basically use Azure Web App for containers. If you want to run microservices, that are in container format, but you don't want to undertake the overheads of managing a Kubernetes cluster and patching them and upgrading them and so on and so forth, you could use Azure Container Apps, right? If there are any event-driven application that you're running and you don't want to basically deal with the underlying complexities of infrastructure, you could use our serverless platform, which is Azure Functions, right? If there are any batch processing, if you are batch processing applications and you would like to use the construct and the benefits of Azure Batch, you could bring your containerized application to Azure Batch, right? If you have if you want to run one-off containers, right, without having to create a VM and then run containers on top of that, you could basically use our container instances platform, right? If you want to basically run a fully managed Kubernetes service, which is where our AKS service comes into play, right? And we'll see, and that is going to be the focus of our discussion today, going forward, right? If you have an if you're an existing OpenShift customer, or if you have applications that run on existing OpenShift clusters and you will basically want to migrate that to Azure, we offer a managed OpenShift platform with Azure Red Hat OpenShift, right? So this is something that we jointly support along with Red Hat, including support and deployment, right? If you have an application that was probably built on using our Service Fabric construct, that is where you can host your application on Azure Service Fabric, right? For hybrid scenarios, you have Azure Arc for Kubernetes, which allows you to manage clusters that are in on-prem or on other clouds as well, right? Now, with these different ways of running clusters, we also offer different toolings and services around it, right? So if you have a container image and you want to host it, or you want to build a container image, or you want to host artifacts like Helm charts, you have something called as Azure Container Registry, right? If you want to automate container, image builds, or if you want to patch those images, you have, again, you can use Azure Container Registry, right? If you have an existing on-prem application and that you would like to migrate to Azure, there is a capability within Azure Migrate which lets you migrate or convert an existing application into a container image and host it on any one of those platforms that we spoke about earlier, right? If you want to monitor the performance of your container workloads on Azure, we have something called as Azure Monitor for Container Insights, right? If there are container application that you're running and you would want to perform threat protection or vulnerability assessment of the container images that you're hosting on Azure, you could use Azure Defender for containers, right? If you want to basically apply policy at scale or safeguards at scale, right, which basically define what is allowed to run on your Kubernetes cluster, what kind of images are allowed to run on your Kubernetes cluster, how should your Kubernetes cluster should look like, then we have something called as Azure Policy for Kubernetes, right? If you have a Kubernetes application that needs to access another Azure service, let's say, for example, Azure Storage or Azure, MySQL database or PostgreSQL, for that matter, instead of configuring secrets in your application, you can use something called as Azure Workload Identity, which lets you authenticate, make service-to-service authentication and authorization, right? If you want to manage RBAC, Kubernetes has a wonderful RBAC construct, but it will mean that when you're running multiple clusters, you have to do it at a cluster level. What if I want to manage multiple clusters at scale? Then we have something called as Azure RBAC for Kubernetes, which you can manage through Azure Active Directory. Okay. Moving on, a couple of other services that we have. For example, if you want to for your applications have persistent storage, then we offer Azure Disks, which is disk storage, which will attach to your VMs as well as AKS clusters. If you require shared storage, which is NFS or CIFS or SMB based storage, we have something called Azure Files. We also have NetApp as a service. So for high performant storage clusters, we offer Azure NetApp as a service, which lets you run an entire NetApp server or a storage without having to manage the underlying hardware, right? So if you have any application that runs on Kubernetes and you require application level networking at scale, we have our own version of Open Service Mesh, or you could bring something like an Istio or Envoy for that matter. Right. If you have secrets that need to be used in your applications, or you have keys or certificates that need to be used in your containerized applications, we have something called as Azure Key Vault, right? If you want to perform GitOps for your Kubernetes clusters and your applications, you could use the Flux cluster extension for AKS. Okay? If as a developer, let's say I want to run and debug my code on Kubernetes clusters, so there is this VS Code extension called Bridge to Kubernetes, right? If you want to do automated deployment of your application, including creation of the clusters, and something that I'll show you with a demo later on down the line, we have both options available in GitHub Actions and Azure Pipelines. If you have a workload that requires confidential computing through trusted execution environment, also there are specific virtual machine types that are available on Azure where you can run these workloads. If you want to configure layer 7 load balancing, we have something called as the app gateway ingress controller that lets you do something like this. Okay. And finally, after you deploy your cluster and you want to basically figure out if there is any kind of optimization or best practices that need to be applied, we have something called as Azure Advisor, which you could run against your Kubernetes cluster and figure out if there is something that is missing and apply those best practices on your clusters. Any questions so far? I'll pause for quick reactions.
I have a question, Allan. So can you just talk a bit more about Flux cluster extension?
Yeah, so basically, this is the idea here is to maintain. So one way to deploy your application is deploy your Kubernetes cluster separately through maybe Terraform or an Ansible or an ARM code and so on and so forth, which I'll talk about later, and deploy your application through something like GitHub Actions or Azure pipelines, right? But what if I want to basically maintain the entire deployment end to end, including like things like creation of namespaces and creation of config maps and secrets and all of that within my application. So we have this Flux cluster extension for Kubernetes clusters that could be applied to AKS clusters running on Azure, as well as clusters that are running in a hybrid environment, right? Whether those clusters are running, let's say, on premises or they're running on other clouds, right? For example, AWS or GCP. So you could basically from a central console manage all of the deployment in one single place.
Got it. Thank you. Thank you. Is there any questions from the audience at this point? Just post your questions on the chat. Else we can just move on and take questions at the end as well.
Sure. So with that, we'll move on to now, if you have decided as a developer that you would like to host your application on AKS, what are the various ways of deploying AKS on Azure, right? Um, so to begin with, let me quickly talk about for folks that are probably new to Kubernetes. I thought maybe I'll just give you a brief overview. It is not meant to be an exhaustive overview of Kubernetes, but just a brief overview of of a typical Kubernetes cluster or the components of a Kubernetes cluster, right? You have something called as the Kubernetes API server, right? Which is how you basically interact with the Kubernetes cluster and basically configure your Kubernetes cluster, right? The API server interacts with a database, which is called HCD, which is basically a key value store, which is where your configurations are stored, right? All of this is typically hosted on something called as the master node, which is basically a set of virtual machines, which has two other components, which is one is the kube scheduler, which basically creates or scales your applications on the application nodes, right? Then you have the controller manager, which basically performs actions such as replicating your pods or handling node operations, right? Then finally, you have the worker nodes or the application nodes or the agent pools, right? Which is where your application is going to sit. Now, on the worker nodes, you have something called as the kubelet agent or the Kubernetes agent that processes the orchestration that are received from the master node, right? This includes scheduling of the pods and running of the containers, right? And then you have something called as the kube proxy, which basically handles the virtual networking on each of these nodes. So the kube proxy basically routes your network traffic and manages the IP addressing for your Kubernetes services and pods that are hosted on the Kubernetes cluster, right? So this is at Kubernetes 101. With that, we'll basically see what it looks like if you were to run Kubernetes without AKS, right? So if you you could host an entire Kubernetes cluster and configure entire Kubernetes cluster on Azure or purely virtual machine. Now, if you were to do that, you have to deploy a set of virtual machines for your master nodes and a set of virtual machines for your agent nodes, right? This gives you complete control over the cluster control plane, right? You could decide various things such as things like, what kind of container runtime do you want to run, what kind of ingress controllers what do you want to run, and so on and so forth. The reasons for implementing something like this would be, let's say, for example, you want to be sure of moving the cluster to another environment later on down the line, or if there's the organization of your organization has some sort of a multi-cloud strategy, right? But then it has lots of overheads of trying to maintain the master nodes and the worker nodes, and keeping up to date with the various Kubernetes release cycles and so on and so forth, right? So a lot of the heavy lifting that you'll have to do if you were to deploy an entire Kubernetes cluster by yourself, right? So the easy way out here is to basically deploy AKS. What AKS basically does is automates the entire deployment of your cluster, and the control plane, which is the master nodes, is handled by Azure for you, right? The other benefits are basically integration with things like Azure AD, things like integration with Azure Monitor, and the other benefits that we spoke about, the tools and services that we spoke about earlier, right? So if your focus is to not worry about how this infrastructure is set up and basically rapidly deploy my application, and then basically quickly deploy your application. So in this case, you will basically deploy AKS and then use the rest of the tooling and services that are available for you and implement your application, right? Now, what does a typical AKS deployment look like, right? The first step will be for you to create a cluster, right? Once your cluster is up and running, the next step for you is to deploy your application on the cluster, right? Once your application is deployed on the cluster, the third step will be for you to publish whether if the application is going to be used internally or externally to the outside world, various, using various options that are available on Azure. You will also then basically take decisions on how will you scale your application in response to user traffic and so on and so forth, right? And finally, as once your application is deployed, you will obviously go through some sort of an application lifecycle, which includes updating newer versions or updating the underlying libraries and frameworks and so on. right? So broadly, in any deployment, these are the various steps that will be involved, and we'll see how you could basically go about planning and implementing these steps in your environment. Okay. Any questions so far? Otherwise, we could move to the next pop quiz. Okay, so here basically a quick maybe you could put that in the chat. If you could, if you can tell us how many ways are there to run Kubernetes AKS clusters on Azure. So the most favorable answer seems to be 7, and the answer is actually 7. Yes, we'll see what those options are, and we'll go into details. The most obvious way is you go to the Azure portal and basically create a Kubernetes cluster, right? And I'll walk you through a quick demo on some of these options. The other option is to basically use the Azure CLI and create your cluster, right? The other command line that we have in Azure is PowerShell. So if you are a developer who is familiar with PowerShell and would like to use PowerShell, so there are PowerShell commandlets that are available for you to do that. The fourth option is Devops Starter. This is quite interesting. This basically sets up your cluster and a starter application for you end to end, including things like application monitoring and log analytics for your container application monitoring and so on and so forth, right? It also includes an ARM template for you, which also deploys the cluster, right? So basically, what a Devops Starter essentially does is creates an entire cluster for you, including all the typical surrounding services that you will need to get your application up and running, right? The last three, yes, they are ISC tools. There are various options available. If you're somebody that is familiar with ARM templates, you could use ARM templates, or the other newer version that we have is something called as Azure Advisor, which basically hides a lot of complexities that are there with ARM templates, right? If you're somebody that is familiar with Ansible, you could bring your Ansible playbooks and deploy your cluster using Ansible playbooks. Or if you're a organization that is familiar and uses Terraform quite a bit, you could basically use Terraform to deploy your clusters, right? With that, I will just quickly switch over to my desktop. Just give me 1 second, and then let me know if you can see my screen. Can you see my screen? I hope it is visible.
Yes, it's
okay.
visible.
Thanks. Okay, so we'll quickly look at the various options that you get when you set up a Kubernetes cluster. So if you are on the Azure portal, you could basically search for Kubernetes services and say create a new Kubernetes clusters. Now, when you create a Kubernetes cluster, there are various options that are selected as default. I'll quickly highlight some of the important ones. So we have something called as the preset configuration, right? The preset configuration basically configure some of these things like if you require a hardened access, which is basically for environments that require security, advanced security, and so on and so forth. So it basically deploys, as you can see out here. It basically implements some of those things and pre-configure some of these things for your cluster, right? One of the things that it does is that in standard you will have something called as the public cluster, right? Which means the API, the Kubernetes API, is exposed to the public internet, right? Whereas if you select the hardened option, it creates a private cluster using Azure Private Link, right? A couple of other things that it also implements is Azure Policy and availability zones, which basically make sure that the node pools are spread across multiple zones, right? And also basically configures key vault integration using the secret store CSI driver, right? So if you're basically it's probably maybe a MVP application that you're going to run, and you are concerned about cost, you could basically select something called as the cost optimized option, right? So it the Preset basically takes away a lot of the decision making that you probably have to do to decide what kind of cluster and what kind of configuration that needs to be implemented, right? A couple of other things to be noted. If there is this the API server availability, which is basically your master node, right? So if depending on the SLA that you will want for an API server, right? You could choose one of these options, right? So if you select the 99.5 option, this basically does not incur any charge for your master nodes, right? Whereas if you, let's say, you want to ensure that your master or the API server is also highly available, you could select the 99.9 option, right? Or the availability zone option, right? A couple of other things that to be aware of. You can in the node pool section decide the number of agent pools that you want to deploy for your cluster. You could decide the encryption type, whether it is through the platform managed key, or if you want to bring your own key to encrypt the disks of your cluster, you could use the customer CMK keys as well, right? In the access section, you will decide whether this cluster needs to be AD integrated, right? So this is where you could either use managed identity or service principal. Service principal requires you to basically maintain the service principal and all of that, whereas managed identity is basically a wrapper service around service principal, and it automates the the requirement to rotate your service principal keys and so on and so forth, right? So the recommended method here is to use managed identity. If you want to use the Azure RBAC, you could enable this. Otherwise, it will default to the Kubernetes RBAC. If you select the AKS managed Azure Active Directory, you could define the AD groups that have access to the cluster, and you can define certain roles that have, or you can use leverage some of the built-in roles to decide which a user or a administrator has access to the applications within the cluster. On the networking side, you have options to either select Azure CNI or Kubernetes. Azure CNI is the preferred option. Kubernetes basically creates its own networking for you to deploy the cluster. In Azure CNI, the nodes as well as the pods are deployed in the virtual network, right? The same virtual network. This is the preferred option especially if you want to basically make sure that your application is accessible from other networks, especially when you have a hub and spoke network topology, or if you have an application that needs to access that is probably something that is running on premises, right? So when you select CNI, you have to specify the virtual network that needs to be part of, and then you have to basically also specify the service address ranges and the bridge addresses and so on and so forth, right? The service address ranges and the Docker bridge addresses is something that you could probably reuse across the clusters, but these need to be unique and should not be conflicting with any other IP address that is on-prem. Okay. In terms of load balancer, it defaults to, this is basically the L4 load balancer through which the Kubernetes services will be exposed, right? HTTP routing option is not meant for prod use. This is something that you will use for maybe in a dev and test environment, and you don't want to go through an ingress controller and so on and so forth. Because I selected the standard option, which is why the private cluster here is disabled. Whereas if you select the hardened option, the private cluster will be enabled by default, in which case the API server has a private IP address, right? Couple of other things I'll quickly talk about. One is the integration with the container registry. You could basically, at the time of creating the cluster, specify the container registry that needs to be integrated with the cluster and the log analytics workspace that it needs to be integrated with. Similarly, you could also define the Azure policy, whether it should be enabled so that you can define, policy standards for your cluster. Okay. So in the advanced section, you can define if the cluster requires a key vault store. You could enable the CSR driver so that your application on the Kubernetes cluster can access keys and secrets on the via the key vault. And I'll also quickly, given that we are here, I'll also quickly walk you through the Devops Starter option. So the Devops Starter option I have pre-created here so that we save some time. So as you can see out here, it does end-to-end deployment of the cluster, including the application code. So it hosts, in this case, I've hosted the application code on a Azure DevOps repo. I have it has automatically configured build pipelines for my application as well as my release pipelines. And you can see on my right hand side that the application is already published, and it has already has a, in this case, I've hosted a Spring application. It has a public endpoint already configured for it. It has also a pre-configured application site, so I can out here in the same dashboard, I can see the application related metrics. I'll just do a quick walkthrough on what things are hosted on my DevOps. So when you create a Devops Starter project, as you can see out here, the application repo is hosted under the application folder. You could basically replace this with your own application binaries. In the ARM template section, it has a template that is available for you, which you will reuse or modify as per your requirements. And the pipelines are already, the build pipeline, as you can see out here, has it's pre-configured for to deploy to build the application for you, right? The release pipeline contains all the tasks that are that are required, where basically once once your application is built, the relevant tasks around picking the container images from the container registry, deploying the application through Helm charts, and so on and so forth. Any questions so far?
Yes, there is one question from Murli, specifically from the deployment perspective, that is API server, that is the Kubernetes master node, right? The which is there. How do you scale? So how do you come up with the scale perspective, help the customers from scale, from a high availability perspective, in fact?
High availability. Can you repeat that exercise, please? Sorry, question, please.
So the question is, you have an API server managed on Azure. How this will help the client from high availability perspective?
High availability of the API server, you mean?
Yeah.
Yeah. So so the API server, the master nodes or the API server is basically managed by Azure. There are two options available for you. If you want a certain SLA or a certain commitment of reliability, a certain commitment of assurance of availability, there is a paid version of the API server, and there is a free version of the API server, right? So that is something that you specify at the time of creating the cluster, which is the first screen that I showed earlier. That is where basically you can decide at the time of creating the cluster whether this cluster will use the whether the master nodes are are free of cost, or if there is a certain assurance of availability that you need, you can configure for a certain fee. You can decide the availability of the API server. I hope that answers the question.
Yeah. I think Murli, is that fine? You were clear with that? And Murli has another question. Okay, is there any exercise? Yeah, there are quick start guides on this, I believe. So let me post that one as well.
Sure.
Cool. Yeah, that answers for him.
Okay. So I'll just quickly run through the remaining slides. So I don't want to basically go into the details. So in the CLI, there are like 8 different steps that we'll have to basically run. Basically, you are creating a resource group, you're creating a virtual network, then you're creating an AD group, which will have access to your cluster. You are then creating a user account, or you could use an existing user account and adding to the group, which is step number 5. Step number 6, which is where you are adding the user to the group. Step number 7 is where you're creating the cluster. Essentially the same set of options that we selected in the Azure portal that we saw a little time earlier. Right. The last step is basically to fetch the credentials, at which time, if you have done a AD enabled cluster, you will basically be prompted to authenticate using device login. Similar steps when you do a PowerShell based deployment. Basically, you will replace the similar steps with PowerShell equivalent commandlets. Right. Devops Starter is something that we saw a little bit earlier. ARM template. Just quickly here, this is the bare minimum that is required to deploy a cluster. For brevity, I have not included things like managed identity and AD integration and RBAC and so on and so forth. With this, this will basically set up a 3-node cluster or with a certain node size and so on and so forth. Okay. These examples are also available in the docs. We will share that separately. In case if you're deploying your cluster through Ansible, again, similar steps, you will have a resource group defined, you will define the name of the cluster, you define the location and the service principals or the managed identity for your cluster and the node sizes. So something similar will be also there for when you're using Terraform. Okay. With that, we'll move on to deployment best practices. Now, in case of deployment, there are essentially 3 areas. One is from a cluster operations perspective. The second is from a cluster security perspective. And the third is around app development, right? So if you're a cluster operators, first and foremost, basically, while you can easily create a cluster, as you can see, the idea is not to create many clusters because that will mean that you will have to manage those clusters, upgrade those clusters, patch those clusters, and so on and so forth, right? So having less number of cluster helps when you are when you have multi-tenant applications or you have multiple applications or different departments sharing the same cluster, you could leverage Kubernetes namespaces to create logical isolation boundaries within your cluster, right? Next one is basically, this is something we see very often. When you deploy a cluster, by default, as you saw in the deployment, it creates a API server with a public endpoint. And then since the API server is from where you will basically manage your cluster, if it is not secured, it will mean that somebody could inadvertently get access to your cluster. So it is super important that you restrict the access to the API server through authorized IP ranges, or you implement a private AKS cluster, right? Definitely all access to the cluster should be through some bastion host or through some jump server, right? The next thing is basically once your cluster is up and running, it'll probably will be a good idea to configure and apply resource quotas, right? These are basically limits that you apply, while basically a developer can basically define the resource limits in the YAML definition for the application. It'll also, as a cluster operator, you could basically define quotas at the namespace level as well. Okay. From a next thing from a cluster operator's perspective is basically the definition of this pod disruption budgets. So basically the pod disruption budgets basically define how the cluster will react or how your application will be deployed in case of voluntary disruptions or involuntary disruptions, right? Involuntary disruptions are basically where there is an underlying hardware failure, or there is, let's say, a VM is accidentally, a node VM is accidentally deleted, or the VM is shut down, right? And involuntary disruptions is something that can be mitigated by using multiple replicas of your pods, so that if one of the node goes down, your pods are automatically spawned on other available nodes. Voluntary disruptions are basically events that are undertaken by a cluster operator, which includes cluster upgrades or patching or application deployments, right? You can use the pod disruption budget specifically for the voluntary disruption scenarios. That lets you plan how your deployments or replica sets respond when a voluntary disruption event happens, right? If, let's say, when you upgrade a cluster and you have configured a pod disruption budget, the Kubernetes scheduler service that we saw earlier will automatically schedule these extra pods for you on other nodes before allowing the the disruption event to continue. Right. Essentially, what happens is the scheduler waits for a reboot of a node to occur, and then basically schedules the specific number of pods on the other surviving nodes in the cluster. Okay. When you have resource-intensive applications, some case, for example, an ingress controller, you will want to basically define where they can be scheduled, right? So you can configure something called as a taint and a toleration to define where these pods are spawned and the nodes that they're allowed to spawn, right? You could also then use something called as a node selector to basically define labels on or define a label for your node to indicate that a particular node can be used for spawning your application, right? For example, could be, let's say you have an application that requires GPU based VMs, and in your node pool let's say there are specific node pool with a GPU VM. You could basically say apply a label to those node pools and define that these set of pods should be always be spawned on that node pool. Now, in case of node selector, if the node is still you can still basically the pod can still be spawned or scheduled on the label nodes, and basically it allows you to use unused resources on the nodes and basically find a matching node selector, right? And using node affinity, you can basically prefer match. And basically, there are two options when you configure node affinity. You could either say that node affinity requires a particular match to occur and only then spawn or schedule the service, or you can say that it is preferred. In which case, if a available node is found, it will the pod is scheduled, or if it is not, then it will basically spawn the pod on any available node. Okay, there are other things that you could use to optimize the deployment of your service on the Kubernetes cluster. You could basically use, for example, if there are, let's say, web application or web components that are hosted on your Kubernetes cluster, and you want to make sure that they are all hosted or co-located on the same node, you could use affinity rules to do that, right? Or if you want to basically ensure that some of your pods are not hosted together, for example, maybe a backend application or a data application that runs, you could basically say that maybe the web and DB are not running on the same node. Okay, a couple of other things that we recommend that we saw a little bit earlier. From networking point of view, we recommend that using CNI. This is especially important if you want to integrate your existing virtual networks, or if you are application that need to integrate with services that are running on premises, right? For applications that require HTTP or HTTPS traffics. In that case, basically configure ingress controller. You could either use the ingress controller like Traffic or Nginx, or you could use the Azure Application Gateway ingress controller. In which case, the Azure Application Gateway natively integrates with an AKS cluster. Definitely, especially if it is an externally facing application, you should implement a web application firewall and scan for your application for any potential attacks, right? From a security point of view, you could also use network policies to ensure that only certain set of pods can communicate with each other, and if there are other pods, they are denied traffic. As mentioned earlier, you should definitely consider and use Jumpbox or an Azure Bastion service to connect your AKS cluster, right? Now, this is especially important, especially when you're hosting a data workload on your Kubernetes clusters. The node size is important when you use when you attach storage to a node pool, right? For example, let's say you have B2MS VM or a DS2 V2 VM, both of them have 2 cores, right? But a B2MS VM will only support 4 cores, whereas a DS2 V2 VM will support 8. Not 4 cores, 4 disks, and a DS2 DS2 V2 VM will support 8 disks, right? The other thing is a B2A MS VM will support only up to 1900 approximately IOPS, whereas a DS2 V2 will support 6400 IOPS, right? So essentially, depending on what your storage IOPS requirements are, or node sizing will be important for you in such cases, right? If there are requirements where you need to back up your data, you could use something like Azure Backup or Velero. If there are scenarios where you need to deploy BCDR, you should explore a multi-region AKS deployment, right? Now in India, we also have availability zones in central India, so you could also have a zone redundant AKS deployment as well, where your node pools are spread across multiple zones. especially when you run AKS clusters, we do an N-3 version support. So this is something that we see often while you will have deployed your clusters, and especially when you have a large number of clusters, keeping up to date or keeping current on your AKS cluster becomes challenging, and this is something that you will have to maybe operationalize as part of your day-to-day cluster operations. Definitely, any application that runs on your AKS cluster will require some kind of log aggregation tool. You could bring your own log aggregation tool using, any one of your favorite ones, or you could use Container Insights, which is available in Azure Monitor. Okay. From a security point of view, definitely you should consider using AD integration. This lets you basically, instead of having multiple SSH keys, this lets you use the SSO capabilities of Azure AD. The other option is also look at Azure RBAC, where you can define the users and the groups that need access to your cluster resources in a central location rather than at each cluster level. The next one is basically you should consider using managed identities for your AKS clusters instead of service principals, given that service principals require you to rotate the keys over a period of time. Right? I believe it is some 45 days odd, after which you'll have to rotate the keys, whereas these things are automated for you in case of managed identity. Definitely, when you're using Azure Container Registry, use managed identity, because in that case, the AKS can fetch or authenticate with your container registry using an AD credential. The next thing is um, uh, to ensure that all your clusters adhere to your certain organization standards. For example, if you want to ensure that all your Kubernetes clusters have a private endpoint, you should definitely consider Azure Policy, which lets you define what your cluster should look like. Right? Basically, you could define things like whether your Kubernetes cluster is allowed to have a public API, whether things like disk encryption on the node pool, whether it should be based on bring your own keys, or whether it should be Azure managed keys, or whether it should have, let's say, key vault compulsorily integrated, whether the version should be of a certain, the version of the Kubernetes cluster is of a certain configuration, and so on and so forth. You could also basically define things like whether the developer is allowed to run privileged containers, which are not recommended on an AKS cluster, right? Then from a threat protection and vulnerability perspective, you should definitely integrate Defender for Container, which basically looks at if there are any container applications which probably are, are malicious in nature, or have vulnerabilities in the framework that need to be patched, right? Last but not the least, always make sure that you whitelist the sources or the registries from where your container images can be deployed. From an app dev perspective, as an end developer, some of the things to consider is definitely definitely define the resource limits so that you're optimally able to consume the resources, the compute resources within a cluster, right? More often than not, we see that applications are deployed, but there are no resource limits deployed, and then suddenly you have applications failing because you're exceeding the compute limits, right? A couple of other things from a app dev perspective is consider maybe look at configuring liveness probes, which basically lets you know, which lets the Kubernetes cluster know when to restart a container. For example, if there is a container is not responding, then maybe the cluster, the Kubernetes cluster can take proactive action in restarting the container application. You could also implement something called as the readiness probes, where you can basically define or let the cluster know, or Kubernetes know, that a container is ready to start accepting traffic, right? A startup probe is basically lets you know that the container application has started, and it all basically, for example, you might have an application that is slow to start. You could definitely consider looking at implementing startup probes, so that the liveness checks and the readiness checks basically don't fail unless until the startup is completed, right? Um, um, Other thing is when you deploy your application, maybe consider using tags. tags not only for the resources that you deploy within Azure, but also tags for the application that you deploy on your cluster, right? And tags could be useful to maybe use Azure policy to specify that what kind of policy should be applied based on a certain business or a security or a technical tag, right? Definitely implement auto scaling. Auto scaling can implement it through horizontal pod autoscaler or through KEDA, right? Definitely consider using Azure Key Vault, so that you don't inject or don't keep any secrets in your container applications, right? And these are kept out of band in your Key Vault, and that is something. So even if there's a key, secret change, you don't have to redeploy your application. This could be basically accessed through the Key Vault. Finally, look at workload identity, which helps you basically, instead of using connection strings in your application code for, let's say, for accessing your storage or accessing databases, you could basically use workload identity for these scenarios. With that, we'll move on to some of the reference architectures that we have. I'll just quickly complete this section and then we'll probably go on to the Q&A. So we have different, I'll quickly give you a brief of what these are. Now that you've understood the, the various deployment options and the various best practices of running AKS on Azure, we also have a lot of material available for you to reuse and consume in your organizations, right? So there is something called as the Azure baseline architecture. This is basically for somebody who's starting new. You could use this as your starting point, and it contains a lot of these best practices that you spoke about earlier, right? This is infrastructure focused. It doesn't talk about the application itself, and basically includes all of these best practices and recommendations as far as the infrastructure is concerned, that we spoke about earlier, right? Now, there's another version of this, which is called the multi-region baseline architecture, which basically builds on the baseline architecture. And basically here it talks about if you have to deploy a Kubernetes cluster that spans across multiple regions, what are the things that you should consider, right? For routing your application traffic between multiple regions and having a highly available configuration, right? If you have a workload that requires to be, let's say, PCI compliant, we have another iteration or version of the baseline architecture, which is called the regulated workloads baseline architecture. This adds guidance from a PCI perspective and recommendations, and basically all of these baseline architectures contains a reference architecture, and that is available on the GitHub repository that I've referenced out there, and it contains ready to use templates for you to actually implement this and customize this in your environments. Finally, we also have this microservices baseline architecture, which basically contains app-specific guidance, right? Things like network policy configuration, for your services on the Kubernetes cluster. Things like how you should do distributed tracing and pod autoscaling. Okay. Now, if you're an enterprise and you're looking at implementing an enterprise scale landing zone, we have something called as an enterprise scale landing zone architecture, which covers various scenarios. One of the scenarios that it covers is AKS also. Basically, this is a reference architecture for an organization that has, let's say, multiple subscriptions, multiple departments, spans across the multiple regions on Azure, and it includes collection of ARM templates and Bicep and Terraform templates that you could again reuse out here for your enterprise needs, right? Within enterprise scale, there are these something called as the design areas, and it covers things like identity and access management, so, design considerations and design recommendations. And again, the templates also incorporate these recommendations and considerations here, for your deployment. Things like how should you configure your subscription for your application, how should you configure your resource groups, if this is the application needs to have BCDR, what are the considerations for BCDR and operations baselines for that. This is available on the GitHub repository that I've referenced, the link out there. And then finally, we have this newest offering, which is called Mission Critical. This is not AKS specific. This is basically, let's say you are looking at implementing an application that is of mission critical in nature. It includes guidance for how you should design your application, what are the decision factors that you need to consider for selecting the application platform, the data platform, the network connectivity for your application, what kind of health modeling should you implement, what kind of observability should you implement, what are the tools and process that you should implement for deployment and testing, templates for your CI/CD pipelines, and security and operational practices. When you have a mission critical application, right? This is quite exhaustive in nature. This is, like I said, is not just Kubernetes, but basically end to end, right from things like application traffic routing through front door, and then hosting your application, and if there are any event driven scenarios, you hosting using Event Hub and integrating that with your application on AKS, and then finally the underlying data stores, right? It has something called as the stamp based architecture, right? So if it is a high volumetric kind of application, you will basically also create something called as multiple stamps, which could be hosted on multiple regions or multiple zones if it is an availability zone kind of a deployment, right? Yeah. So with that,
Yeah, there are a couple of
so, yeah.
questions. How do network policies work when scaling of pods?
Okay, so so in this, so see, network policies are basically meant for defining when you have an application running on a AKS cluster, defining which set of application can communicate with another set of application that is probably also co-located within the same cluster, right? So for example, if you want to make sure that, let's say, a certain set of pods can only communicate with another set of pods, you will define that in your network policy, right? For scaling, you will basically so basically it is transparent nature from, I mean, it decouples your scaling or pod scaling from this is from only from a network communication of your interpod communication.
Yeah, I'm just waiting for a response. That answers his question. Anyways, the same person has another question on how is AKS leveraged for microservice-based architecture. I've actually given the link where they can go find more answers to it. But if you have an overview of it, probably you can talk about it.
Yeah. So the earlier the section, I'm assuming that the question is in reference to the baseline architecture for microservices, right? So like I said, I mean, the 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 baseline architecture is mostly infrastructure focused, right? Things like what should your cluster, how should your cluster should be configured, right? In terms of node pools and whether it should be private or public, whether the disk encryption should be configured and so on, so forth, AD integration and so on and so forth. The microservices baseline is the only baseline where it goes into things like auto scaling for your pods, things like distributed tracing for your application, and the ingress routing for your application.
Yeah, Manish has one more question.
Can I take it up?
Yeah, sure.
Sure.
Yeah.
Yeah.
Thank you. It's a very informative session, and we can't stop ourselves asking more things. Sorry about it. So, with respect to one common understanding is where if we go for such applications using AKS or ECS based or container based applications, and if the application needs a lot of data to be handled, yeah. So in that case, how do this perform? Because the one of the concern is that, or my understanding is, because of the containerization, we are adding one more layer on the top of what we have on overlay rather. So so how do this can be a good candidate, or what can be good practice to make a good candidate of any ACS or AKS based applications? Am I clear?
So a couple of things you have to consider when you have, applications that are probably network bound, right?
Yeah.
And this will also be applicable to an extent, for storage bound applications as well. You should definitely evaluate the size of the nodes that you're implementing. Like I said earlier, the size of the nodes has bearing on the kind of IOPS it can handle, and it also has a bearing on the network throughput it can handle. So if you look at our sizing section in our documentation for the various VM sizes that are available on Azure, depending on the size that you select, there are certain limits on the IOPS and network throughput. The other thing is the node pool should enable accelerated network. I don't recall for sure whether it does it by default, but if it doesn't, you should definitely ensure that the VMs have accelerated networking enabled. What happens in accelerated networking is instead of usually going through the hypervisor switch, it basically bypasses the hypervisor switch and directly uses the host networking to access the underlying network. So you get a little bit of latency and network throughput performance, not a little bit, I mean, especially for a network bound application, you will see definitely see an improvement if the nodes or the VM has accelerated networking enabled.
So if I've understood correctly, we should try to leverage the underlay rather than overlay stack. Yeah. So that should be one of
the
things
CNI. Yeah, so CNI should definitely be used, and the VM sizes it should basically be closely evaluated depending on the kind of traffic or volume of traffic you want to handle.
And sorry, if I can ask one more thing, you mentioned about CNI and Kubernetes networking. So what is the actual difference between those two, and when to leverage that?
Right, good question.
Sorry.
Yeah, so good question. So in Kubernetes, it basically, it doesn't, you don't have to specify worry about the underlying VNet configuration, right? But then it gets complicated in terms of if, let's say, your application needs to access another, let's say, virtual network, right? That is paired with the, let's say, the AKS network, or if, let's say, it has to access an application that is sitting on premises, right? So there is basically some sort of complex network routing requirement that is required for an application. In that case, we prefer using CNI because in CNI, your Kubernetes services and your pods, as well as the nodes, are hosted in the same Azure virtual network. Whereas in Kubernetes, the Kubernetes basically manages all of that for you, but there is additional configuration that you need to do to ensure that the application can now talk to your on-prem and so on and so forth.
Great.
So,
Okay.
to summarize, if you have any scenario that requires, let's say, access to another virtual network, especially when you have multiple virtual networks that are hosted in your subscription, or if you have an application that needs to access, let's say, on-prem, or your application, let's say, needs to access maybe a third-party API that is hosted somewhere else, right? In all of those scenarios, CNI will be a preferred option.
Is
For
it
dev and test.
also Sorry, is it also equivalent important when we are using any endpoints to access some PaaS services? Is it good to use CNI?
Yeah, so that is also a good point. So when you access the PaaS services, there are two ways to do it. There is something called as a service endpoint, right? So when you have a application that needs to access a PaaS service, the default without service endpoint is to basically, though it is still on the Azure backbone, it is still an internet connection, right? Now, if you want to basically restrict that access to a particular PaaS service, right? Let's say if you have only MySQL or let's say Cosmos DB or storage for that matter, sorry, in that case, basically you can enable the service endpoint for that set of application in that region, but still it is public in that sense, right? The other option is to enable private link for your PaaS application, and we now support private link for most of our services, in which case your PaaS service has a private IP and the communication between AKS and the PaaS service is on the private network. So depending on the endpoint that you configure for your PaaS service, you will basically have to take a decision on the kind of networking that is enabled.
Great. Just one last question. If we want to really get through what you spoke about, such good practice or best practices, is there any link you can provide where we can go and we can look at such best practices?
Sure. There is a I'll put that in the chat. There is a best practices section in our documentation, AKS documentation, that has all of these the best practices that I spoke about. The other thing I spoke about very briefly, and unfortunately I couldn't demo, is something called as Azure Advisor, right? The
Yeah.
Azure Advisor basically scans your cluster and looks at some of these things and tells you if there is any configuration that needs to be probably be looked at, and it gives you a high, medium, low score, right? And that is something that you should probably scan on a regular basis, or you can also automate that and send automatic alerts for you to be aware of if something is misconfigured. Other thing is, some of these best practices can also be incorporated within your Azure policy, so that somebody, when you provision a cluster, these things are there by default, and if there's somebody tries to provision a cluster which does not conform to these best practices, you automatically deny or audit, right? You can either deny or audit. You can say that administrators cannot provision, or you can say that allow the provisioning, but audit it, so that sometime later you can go and take a corrective action. The third thing is, there are folks that have created various CLIs where you can basically scan your cluster and verify some of these things. The Azure Advisor basically doesn't look at things like, it only looks at the cluster configuration. It doesn't look at look at your application configuration. It doesn't understand whether things like whether you have configured request limits within your YAML definitions and so on and so forth. So that is something that maybe can be incorporated as part of your DevOps pipeline, and maybe put some checks and balances as part of your release pipeline, and see that if somebody is deploying an application, and in that pipeline, if these things are found, you basically stop that deployment or take some corrective action.
Or send alert or notification, maybe.
Something of that sort, yeah.
Yeah. Great. Thanks a lot. It was really fantastic. Thanks a lot for all this information. Thank you.
Thanks.
Any more questions from the audience? You can also unmute. The mic is available. While we wait for some of the questions, there is a survey link. Key in that event ID, which is 15786, and take this survey and let us know how was the session, and what are the sessions you want from the reactor, and we will try and make sure that we get those sessions for you. But do ask questions to us. We can still be here for 5 more minutes. Right, Allan?
Yep.
So sorry, a short question. Can you will you be able to share this slides? It was very useful. I mean, if you can. Recordings I can understand, but yeah, slides will be really good if you can, if possible.
Yeah, so probably Rashmita, maybe let's see. Is there a way that it can be published? Or
Yeah, we can publish it. We have the meetup.com, but is it something which you can share? If it is, then we could.
Sure. So maybe separately we can send a notification or something.
Yeah, we can. And but this is anyways being recorded, and we will anyways publish this on the YouTube channel, so you can also verify these slides or check these slides through that recording as well. But we will try to publish it, and we will have to go back and check whether we can publish it and other things. Rashmita, is there anything specific things you want to talk about?
No, I'm good. I think we don't have any more questions, so we can wrap up for today. So thank you so much, Dahnesh, Allan, and Vivek for the session, and thank you all for joining us. Please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again, and enjoy the rest of your day.
Thank you.
Thank you, Allan. Thank you, Dahnesh. Thank you for joining in, and great session.
Thanks, Arun.
Thank you.
Thank you.